All right, time to turn the page, go to page 2 and question number 5. I think the first thing that you're going to notice in this problem is this wackadoo guy right here, this cube root. He's the problem. So you can't even say, oh, this guy is linear or quadratic. You can't even tell me how many solutions we're supposed to have yet until you get rid of the radical. Now, the way we get rid of the radical is by using the power property, but I can't even use that until the radical is totally by itself. We saw that, excuse me, we saw that a second ago when we had to use the square root property. We had to get the square by itself. So the radical needs to get by itself first. So I'm going to subtract 7 on both sides. So now I have the cube root of 6x plus 5 equals 5 on the right side. Now before I can get to the goodness of this radicand of the 6x and the 5, I have to get rid of the radical. To undo a radical, we raise both sides to a power that matches the index. So I'm going to cube both sides. I'm not going to square both sides because that's not going to do me any good. The power needs to match the index. So when I cube the cube root, I get the radicand, which is 6x plus 5. On the right side, I'm cubing 5, and I get 125. Now that the radical's gone, this is a linear equation. This is just x to the first power. So go through the process to get x by itself. Subtract 5. Subtract 5 on both sides, so 6x equals 120. And finally, we divide both sides of the equation by 6. So x equals 20. And that is it. There is nothing else that we need to worry about doing. You could check this, but again, if you have something like a cube root or an odd indexed radical, the answers you get should be fine. It's when you have something like a square root that you really need to go back and check your work. So x equals 20 is it.